So we want to understand what happens to this. If you have two functions, f at x, g at x, if you were to add or subtract, right, how the graph look like. Okay, so this, I'm going to start with some simple examples, but ultimately we want to do something like this. Like, what would sine x plus x, for example, would look like? We have never learned throughout the whole advanced functions how to sketch this, right? Okay, so let's start with something simple, like y is equal to, or the first function being x squared, and the second function being 3, a constant function. So if you were to add this, we'll just get x squared plus 3, which we know how to draw, right? Okay, but instead of actually going back to the grade 10 rule of, oh, this means you gotta move the graph up 3 times. Okay, let's try to draw it without that rule. Okay, y equals x squared. Okay, looks like this, right? This is the picture of the parabola, right? So adding 3 to it, okay, adding 3 to it. Now, where students usually get confused is adding 3 to y. Are we talking about adding 3 to the x value or the y value at a particular point? Okay. When we add like this, what we're doing is the y value of the y equals x squared, we're adding 3 to the y values, not the x values. So what happens is the x values, like 1, 2, doesn't change. But the y, which where it's 1, it's going to change to 1 plus 3, so it's going to go to 4. This is 4. 4 plus 3 equals to 7, right? 4, 6, 7. And this 0 will go to 3. Look at these 3 points. Right? The same thing will happen to the other side. Okay. Okay, so that's pretty easy. Let's do something, okay, a little bit harder. Okay, what if we had f at x is equal to x squared and g at x is equal to x? Okay, so here again, draw the parabola roughly. But now we have a line. Okay, we have a line. So what would this do, right? So again, we're adding the y values. So at this point, both y values are 0, right? When x is equal to 0, okay, so here, let's do this. X, g, f plus g. When it's 0, this is 0, this is 0, so when you add it up, it's still 0. When it's 1, this is 1, this is 1, this is 2, right? When it's 2, this is 4, this is 2, so it's 6. When it's 3, 9, 3, 12, right? Let's put some negative values in. Negative 1, we get 1, right? 1, negative 1, so you actually add it, you get 0. What about negative 2? 4, negative 2, you get 2, right? So let's plot these values. Two zeros here. There's a 0 here and 0 there. Okay, so when x is 0, it's 0. And when x is negative 1, it's also 0. Okay. So what else do we have here? When it's 1, it's 2. And when it's, let's pick, when it's negative 2, it's also 2. Okay, so we have these 4 points. We have 2 roots here, right? So you know, aren't you curious? Like, a negative half, is it going to go up or down? What do you predict? Is it going to go up or down? If you add a y value here, here's a y value, right? Which is about half, right? And here's a y value too. If you add this y value on the line, will this y value go down or up from where it is?
Down.
Down. So it'll certainly go below. Okay, it'll sort of go below. And my picture is not really to scale, so if you were to do it more accurately, we can put in negative half. Then you get a quarter, negative half. If you were to add this, what do we get? Negative a quarter, right? So we get right here like this. So now we have a central point. It's going to go back up. Let me use a different color. So it's still a parabola. But what's important from what we just did is like, okay, well, seeing the y value, if you are to add, what happens? You can intuitively tell that it's going to go down, right? But you can confirm it by plugging in a value. Now this here, if you were to add these two, you get y equals x squared plus x, which is y equals x squared plus x plus a quarter. So you get this. So it's a parabola with roots at negative half and negative a quarter. So that's exactly the graph we have, right? Make sense so far? Okay.